Thank you, Elisa. Hello, everyone, and welcome to today's webinar, Unlocking Subsurface Secrets with Velocity Modeling in GVERSE Geophysics. The agenda for today is as follows. We're going to start off by looking at velocity modeling inside of GVERSE Geophysics. Then we're going to look at the velocity modeling methods offered. After that, we're going to look at the visualization of those velocity models and the results. Now let's go into GVERSE Geophysics for the demonstration. Depth conversion is an important piece of seismic interpretation because it ties geological data to geophysical data. Within GeoGraphix, there are many different ways to perform the depth conversion. Now this depth conversion right here is a synthetic. This was built in SynView inside of GVERSE Geophysics, where we can do detailed synthetic work, including log processing, creating analytical wavelets, wavelet extraction, well tying, as well as correlation analysis. Now you build a synthetic to tie the well to the seismic, which is a form of depth conversion, but that kind of limits that to just the one well, right? So you get the velocity table for that 1D well tie. So at that location, you've got it pretty good results, but your seismic volumes of the area you're looking at doesn't have wells all over, or it doesn't have wells that you can use for those ties. That's where creating the velocity model comes in. When you're looking at the well and you want to extrapolate or use information that you have on those wells to see how the velocities vary across the entire survey and then convert that into depth. Now here in my depth conversion tab, here coming into my depth conversion tab, I can see my different velocity model features and my different velocity model types. Now GeoGraphix gives you several options for creating velocity models. Number one is a triangulated velocity model. So simple triangulation. We take time depth tables from all the wells that you can see. Well, not all the ones you can see, but all the wells that have time depth tables in all the wells that have time depth tables, and we triangulate between them. So we take the velocity table for this one well that could be coming from a synthetic, could be coming from a check shot, or time depth that were manually entered over inside of WellBase. Or inside of our well top section here in GVERSE Geophysics. However you set your time depth table. We just take the time depth tables from every one of these and kind of triangulate between them to give you a velocity model for the whole survey. So that's good for a starting point when you're just kind of starting work and you don't really have a good handle on your horizons and your structure. But it's a very crude model. It doesn't take into account any structure or anything like that. So when you want to build a little more sophisticated model that takes into account all the structure that you see inside of your seismic, that's where you create a model other than a simple triangulated model. If I come here and create velocity model, I'll go ahead and bring this down. Over here. Now, here in the Create Velocity Model dialog, I can see that there are options for some more sophisticated models. Let's start with this first one here, the Horizon Formation-based velocity model. And what it does is it lists all the horizons that are in your interpretation that you have available. Now, each horizon, when you create it, you associate it with formation. And what that really means is that essentially that horizon is basically on your seismic. It's a representation of a subsurface structure, right? That's the formation. So you're just saying that in my seismic time, horizon FS8 is a representation of the FS8 formation and the wells that have this FS8 pick. You pick tops in your wells for the FS8 top formation, and those picks are obviously shown in depth. That horizon that you pick on your seismic is going to be in time. So when you have a horizon picked, that's your time value for every well in the interpretation that we have available. We look at the formation picks associated with that horizon, and that gives us TD pairs. So now you've got TD pairs for every horizon well intersection that every horizon that you take on from here. But once you have those TD pairs, then we grid along the horizon using these gridding parameters down here. using these gridding parameters down here to give you more control over how this is going to be grid, to wind up with the results of either average velocity or interval velocity, which can be chosen up here in blue. And that's basically how you create it. So what this is doing, it's taking information from the well logs that you have picked, or tops that you have picked, and the information from the seismic, and then it's using that information to create a velocity model. Now here in version 2026.1 Vega, we have some new features that we've introduced. Number one is here, now you can come in and you can set the horizon order. So I actually come in and I can order my horizons by using this arrow here. Because for velocity modeling, essentially what you're doing, interval velocity models, you need to have the horizons in stratigraphic order. Now in the past, we've used the formation strat order set from Strat Column Manager, but not everyone sets that. So in the past, that meant you had to go back to your strat column and fix that and have to leave from GVERSE Geophysics to go into the Strat Column Manager. So now you can do all of that here from right in this area. Once I can set all of my strat column horizons, I can continue forward with my workflow. Now the second new feature is now I can customize my well list. So I can come here and actually select my wells. So in the past, it was all or nothing. It would take all the wells in your interpretation and use that for the horizon formation based velocity model. But now you can choose. So you had to use all the wells and now none of them, or I can customize this and say I don't want to use these last three in my interpretation, giving me more control over what information goes into my velocity model. So now I can move these if they have bad data or not the correct data that I'm looking for, and now I can see that that's been updated to my 4 selected wells. So now my velocity model will only have those 4 wells when I build my model. Data from those 4 wells is going to be taken in and the rest will be ignored. And that's a pretty crucial piece which gives you a lot more control over the data going into this overall model. And of course, when you create the model, we do save all that information. So we know which wells are used, as well as retaining all of the settings here, which we can see in our velocity manager, which I'll show in a little bit. And this is completely iterative, so I can always come back in and edit that horizon formation based model, reselect my wells, add in more wells if I decided that that was not correct and I wanted to add that back in, and I can iterate through my velocity modeling workflow. Now here in my horizon selection, I do have some other options that I can include in my horizon formation based velocity model. Now, to add more granularity, I can come in and add control points. Now, these control points can be in depth or in velocity, coming from a driller or coming from a depth grid. So they can be imported or digitized on a map directly here in GeoGraphix. Telling you at a certain XY location, you know the depth of this time horizon, and that isn't a well location. So you can always add these control points into your interpretation by checking these boxes here in this area. It won't just go for TD pairs at the individual well locations where your formations are. It'll actually pull in those control points and utilize those as well. So that gives you a little more control, or a lot more control, better yet, over what goes into your model and how you want to shape it. You can also, in this area, add interwell points. That's basically the same thing as control points, but interwell points are the points you digitize over in GeoPlus that don't fall on a well. They're associated with the formation. They have a source, but they just don't belong to a well. So you can label those as well here for more granularity. The really nice thing here is that if you're using a horizon formation-based model to do your depth conversion, you can use that and then go into a model in GeoPlus for a backdrop. And you can use that in a model, and you can use that in your GeoPlus model as a backdrop. And when you add interwell points during your interpretation, you can actually push those back over into GVERSE Geophysics to point back to Geophysics to update that model without ever having to leave GVERSE X section in GeoPlus. You can view, say you view, add some points, then you say update the model. It'll go back, recalculate the model, and show you the results. So that makes the backdrop live in a sense that you can adjust the velocity model just by adding picks. You don't have to come back into Geophysics and rebuild the model. Over here, you can add multiple observations can be taken into account when you're building out this model. So when you're dipping in and out of a formation, if you see multiple observations, do you want to use them as TD pairs or not? You can make that choice right here. And over here, fault polygons. If you've got fault polygons selected when we grid along the horizon surface, and there's a fault polygon there, you want to break your contours for your gridding at that fault polygon. So that's what you'd select here. So if you've got polygons calculated or digitized and you want the velocity model to actually be aware of those faults, you simply turn them on by checking them and selecting which faults you would want to use. And that's to be incorporated into your gridding. And that's your formation-based model. That's your horizon formation-based model. This is useful when you've got good, reliable picks in your wells, and you've got good well distribution with a lot of picks that you trust and you can rely on, and that you know which horizons map to them. So if you have that knowledge in your area, this is a very useful model. Now, another kind of model that we offer is a structurally interpolated time depth model. And the concept here is essentially the same. If you notice here, what I've lost is my formation tops. Still have my time horizons, which I can come and select. So again, the concept is essentially the same. You choose your horizons, which does the same thing as it does as the model we just discussed. But as you'll notice, it doesn't have any horizon formation association here because it doesn't use formations for its depth source. Time values are still coming from the horizon, but for each horizon at that well intersection, we look at where in time and what time value of the horizon is at that well location, and then we just look up that value in the time depth table for that well, and we get our TD pair. So for example, okay, here at well number 3 in this horizon intersects at 230 milliseconds. What is that 230 millisecond value in the time depth table in terms of meters or feet? And that gives you a TD value. Once you have those TD values, everything else is the same and grades along each horizon based on these parameters, and gives you, again, your average or interval velocity, which can be selected up here. Fault polygons, again, will work the same way, and control points as well. The only thing that's different is the source of the depth. So in the TD pair, the depth is now not being calculated from a formation pick, but instead it's actually being looked up in the TD table for the well itself. If I close this dialog, so that's the two kinds of models Let me come back over in my screen over here. There we go. So that's essentially the two kinds of models that keep into account the structure, because you're gridding along your horizon surfaces. So it's a layer cake model. So it's a layer cake kind of model, and it'll go in and it'll give you that information. So I can see that by coming here, and I'll switch over to my active velocity model. So now I can see that layer cake kind of display here, represented here. So for example, switching to my active velocity model now, this is what it looks like. So I've got these horizons picked, and I've got these velocities calculated based on whichever model I'm using for this particular one. And now it's showing my velocity values here in this display. Now I'm going to come and switch back to my original data. And I'm going to go back and we'll look at a third option that we have here. So here, my other option is seismic velocities based model. So my seismic velocities based model, which can be pretty helpful, especially if you're starting out in an area and you've got your velocity values from a processor. You can use this model, and it's basically just pseudo time depth tables at XY locations. That we got from the processor. It could be time and depth, or it could be time and average velocity, RMS, time and average velocity. It could be RMS values as well as average or interval velocity. If you have that file, the ASCII file, you can just bring it in, configure it, and you can even calibrate it right here with the models with my wells. So if you got a good time depth tables and you know that you know are good, you can bring in time-lapse tables. You can bring these in, these processor velocities in, and you can calibrate your model based off of them. Calculate your model based on the existing time-lapse tables. So it's going to go in, it's going to adjust the model based on those tables. So now you have a more accurate model since those are coming directly from your processor. But again, that's also just only more useful when you're in an area where you don't have a lot of well control and you just want to use whatever velocities your processor gives you. I'm going to cancel out of here and come down in here. Now, the fourth option that we do have is you have the ability to utilize an external volume. Utilize an external volume. So if you already have a velocity model that you've built, or you have a company standard, or you got from a processor or a consultant, you can just say, I don't want to build my own model. I'd rather just point to this external volume. And then instead of calculating the velocities, GeoGraphix will just go and read them for that location from the velocity volume that we're pointing to. So those are the main kinds of models. Now, special note here, you can create as many different kinds of models as you want with different parameters, different algorithms. You can have several of these in here inside of your interpretation at the same time. But we only use one at a given time. And that's going to be your active velocity model. So once you've created a bunch of models and iterate through them, I can switch through and change as I go and iterate through them, pick the one that I think is the most accurate and give me the most information that I know, and then the most information that I would like to know, and then I can see my results here on my slices, on my inlines, cross lines. Excuse me. So once I have that there, I can actually come back in and iterate through my models by coming into my velocity manager. So now I can see if I go to my structurally interpolated time depth models, this gives me a layout of my well count. I used 7 wells, my horizon count, 4 horizons were shown in there. It's essentially a summary of the model. So I can come back in and see what I utilized, what was excluded, included, as well as observation points, and what algorithms and settings were chosen. And again, if I wanted to change something here, say if I wanted to change some of the velocities below my velocity horizon, or I wanted to take out a formation, I can simply edit my velocity model. It takes me back into this area here, and I can sum and deselect or choose different options from there, and then update my model. Now, one of the new features, the other thing we've done in the new version of 2026 is we've added this details for data points option right here. Once I click that, and what this does is it lets me see every point that went into the model. It will tell me for which well, which horizon was used, and what XY location that we put to that model, and what time value, and what was the corresponding depth value. And what was the corresponding depth value right here. What velocity value that gave us and what interval velocity that resulted in. Especially when you're using control points and lots of wells, that's really going to go in and give me a lot more detail about my model. If you see, a bullseye with bad velocities, which point is causing that? What was the formation that I picked wrong? Was the time depth table that I'm using wrong? Is the velocity I'm looking at way off in certain areas? So this just goes in and gives me a lot more information. This goes in and gives me a lot more information about what it is, what makes the model, and it makes the model a little bit more transparent. Instead of just looking at it in seismic and then seeing, okay, there might be a discrepancy over here or in this other area. I might need to change this or that or force a control point, essentially guessing. I can actually try and understand which data point it is that's causing that issue for me. I'm going to come back and change this back to my original amplitude. Okay, now that we have a good velocity model that we like, we can now convert between time and depth. Now I can quickly come in and do that here in my 3D view tab by hitting my time to depth mode. And by zoom out, we can see here, now my axis has been changed to depth. And so I can see that my depth seismic would look like, and you can see here I have, let me pull this down, I can see here I have my seismic pull up, as well as now my wells are all distinguished in depth. So they're using the deviation survey. So my wells are no longer in time, right? They're actually using the deviation surveys and the TDs because now we are in depth. So that's how we're drawing right here. We're not relying on their time depth tables anymore. So when I actually come in here, and when I add in a horizon, I'm going to come in and go in and add my horizon, FS5. You can see now my horizon is in depth. Let's say if you convert it to depth on the fly, so that's a depth converted horizon. Same thing for my faults, for my geobodies, for whatever I add to the scene, it will now be converted to depth. Now, one of the best features of using GeoGraphix is the integration. Not only can I look at this section here in 3D, or even, if I don't like to look in 3D and I rather work in 2D, we have the same button over in 2D. So I can come over here in my 2D scene, and I can hit the same button, TD, and convert that into depth. Now you see my values on the axis are now changed to depth, and I have this displayed over here. And if I were to, wanted to view this as a geologic cross-section over in GeoPlus, thereby combining my geophysical and geological work, all I need to do is say, right-click and say, turn that off, right-click and say, create cross-section in GeoPlus. That's going to go ahead and send that over to GeoPlus, maintaining all templates and seismic backdrops, and create that cross-section in GeoPlus. Now I can start to view that large, and I can, now I have my seismic, I have the velocity model. Now you're viewing the same R-blind that I was looking over at in GVERSE Geophysics. Now in GeoPlus, I'm looking at with my wells, my well picks. I can turn on my different layers, my different surfaces, and continue using my seismic interpretation information to inform my geological interpretation. Now to recap on what we saw here today, we first looked at velocity models, why we need them, and how we can create them inside of GVERSE Geophysics. We then looked at the different models we offer for our different velocity models, including triangulation, horizon formation-based model, structurally interpolated time depth model, as well as seismic velocities-based model. And from there, we were able to see how we can depth convert and visualize, and how we can depth convert in the visualization of our results. Now, if you have any questions from what you've seen here today, feel free to submit them here, and I'd be happy to answer them. If not, thank you for attending, and have a great day.